Hey guys, how's everyone doing? This is Mr. Chavla, and today I'm going to be going over the June 2016 Common Core Algebra 2 exam, Mr. Chavla or Mr. C. So I did numbers 1 through 8 in the first video and 9 through 16 in the second video. So this is the third video for the June 2016 Common Core Algebra 2 exam, and I'm going to be going over the key for numbers 16 to 24, the last 8 multiple choice questions. So let's go and get this baby out of the way. Okay, so number 16. Well, sorry, number 17 to 24, I said. Not 16, 17. We did 16 in the last video. 1 through 8, then 9 through 16. Now this is going to be 17 through 24. Let's go. Number 17. So number 16, I was like, that looked familiar. Looks like I did it in the last video. Okay, so number 17, a circle centered at the origin, which is the point 0, 0, has a radius of 10 units. The terminal side of an angle theta intercepts the circle in quadrant 2 at point C. Let's actually draw a little diagram of that. So when we have a circle centered at the origin, this is the center, point 0, 0, and I'll just call that point O for origin, right? And then it has a radius of 10 units. So it comes 10 units this way, 10 units up here, 10 units, and so on, right? This will be negative 10, by the way, the x coordinate, negative 10 down here, and I know that's not a perfect circle, but so what? And it terminates in quadrant 2. So quadrant 1 is the top right, top left is quadrant 2, 3 is bottom left, bottom right is quadrant 4. There are 4 quadrants in the coordinate plane. Anyway, and then the next thing they say is that the terminal ray. So first thing, the two rays make up an angle from geometry, right? So there's what's called an initial ray, is just a positive portion of the x-axis, with the vertex, which I'll put in blue, being the origin. So this is the initial ray. The terminal ray is the finishing ray that completes the angle. And they're saying it terminates in quadrant 2. So the angle of rotation just goes something like this. So, and then it says it intersects the circle at point C. That's what it says, right? Oh, no. It says it intercepts the circle at point C. So point C is where it crosses the circle. So let's see what else it says now. Okay, so the y-coordinate of point C is 8. Okay, so C has a y-coordinate of 8. So if I take the y-coordinate here, it's 8. So the point C is 8 comma, is something comma 8. X comma 8, where x is unknown. And they want the value of cosine theta. So if you remember the acronym, in 5 the quadrant 1, 2, and so on, the acronym goes all students take calculus. And here's quadrants 3. That is not 3. Okay, 3 and 4, as in the other diagram, right? All positive in the first quadrant. In quadrant 2, S means only the sine is positive. Only tangent is positive in quadrant 3, only cosine is positive in quadrant 4. Only cosine is positive in, let me get that over. All sine, cosine, and tangent are positive in the first quadrant. In quadrant 2, out of those 3 functions, only sine is positive, which means that in quadrant 2, cosine will have to be negative, which eliminates already choice 3 and 4, and we're already down to 50-50. Not bad, huh? Now, and in quadrant 3, only tangent is positive, but we're not in quadrant 3, or 1. And in quadrant 4, only cosine is positive, but we're not in quadrant 4. So that's what we need to know in terms of the quadrant. Now, what we're going to do, and without going into too much detail, we eliminate 2 choices based on the quadrant. Now we need to find out the value. So if I draw a right triangle here, the actual angle is this angle of rotation, but we use what's called the reference angle, which is the angle made by the x-axis and the terminal ray. So just the, and it has to be an acute angle, less than 90 degrees. So if I drop a triangle here, if I draw it again, right, without the circle, and I have point C just right here, and it passes just where it crosses the circle at point C, right? C is x comma 8. This is point C, here's point O, right? They said the y-coordinate is 8, but the radius of the circle is 10. But that's okay, because we have to go up 8 units from the x-axis to get a y-coordinate of 8. Here I have a right angle right here. And here I have my reference angle. What the reference angle will do is it's just going to tell me the absolute value of the sine or cosine. And we know that whatever I get, I'm just going to change it to negative. So the radius from here to here of the circle, because we go from the origin, the center, to the point on the circle, is still 10. So I could use the Pythagorean theorem, but better yet, we have 8 as a leg, and then we have 10 as the hypotenuse. Remember your 3, 4, 5 triangles? There's a right triangle. The legs are legs 3 and 4. The hypotenuse is 5. Then 5 times 2 is 10. 4 times 2 is 8. 3 times 2 is 6. So the length of this leg is 6. Okay? So now that means, by the way, the x value is negative 6 because we have to go left 6 units since it's negative, x is negative as we go to the left of the origin. So now we're going to use the acronym that goes, all right, we're going to use the acronym that goes SO, CA, TOA, where sine is equal to opposite over hypotenuse, cosine, theta is equal to adjacent over hypotenuse. So from this angle, right, this isn't theta, but we could use this angle as if it's theta. What's adjacent is the one right next to the angle, which is this length 6. Then the hypotenuse, which I'll put in blue, is length 10. That's just the longest side opposite the right angle. The other side opposite, obviously the 8 would be opposite. And since we're in quadrant 2, remember, it has to be negative, so it becomes negative 6 over 10, which simplifies to negative 3/5. So cosine theta is negative 3/5. There were a lot of ways we could have done that. That was one of the quicker ways I thought of, okay? I know it was a lot of work. This question was kind of tricky, but let's move along, okay? It's all about trig functions and reference angles and quadrant, like knowing the quadrants, okay? So, number 18. Which statement about the graph of log base C... Number 18. Which statement about the graph of c of x equals log base 6 of x is false? What you want to remember is that logs are just the inverse of exponential functions. So if I have a function f of x equals base 6 to the x power, its inverse, so I'll just change this right here to f inverse x instead of c, doesn't make a difference. It's still the same function, is log base 6 of x. That's equivalent to saying x equals 6 to the y, or 6 to the f negative 1, right? That's this function right here. So they're inverse. So if you know the exponential graph, it has a y-intercept. 6 to the 0 is 1, right? Then it would go through 1 comma 6, right? And then it would increase very rapidly. That's what exponential functions do, because 6 to the second is 36. So it increases very rapidly. It has no, so the y equals 6 to the x, right? Or f of x equals 6 to the x, has no x-intercept because the range is that y is greater than 0. The domain, you could plug in any real number for x and get an output. So the domain is all real numbers, from negative infinity to positive infinity, you name it. So, and then the asymptote is just the line that you get closer and closer but never touch. It's the x-axis. It has no x-intercept. So the asymptote, which means the line that it gets closer to but never touches, is the x-axis, which has the equation y equals 0. Remember the zeros of a function are the x-intercepts? So the asymptote is just the x-axis, which is the equation y equals 0. You reverse that for, if the inverse, everything is the opposite. So if I look at y equals log base 6 of x, just using the inverse property, the asymptote for the inverse, so if I just change wherever I have x, so log base 6 of x, it should have an asymptote, basing off the first one. If the exponential has asymptote y equals 0, its asymptote should be x equals 0, which is the y-axis. So this is incorrect because they want which one's false. It has no y-intercept. If the exponential has no x-intercept, then the log will have no y-intercept. That is correct. And I'll show you guys in a second. The domain is a set of positive reals. If the range is y is greater than 0, then the domain, the opposite, right, for log will be x is greater than 0. So I'm going to actually work this out for you guys to show you guys how it works, okay? The domain is x is more than 0, and the range, if the domain of the exponential is, and by the way, x is more than 0, it means positive real numbers, right? Positive means greater than 0. The domain of exponential functions is all real numbers, so the range, the opposite, the y values, will be all real numbers for the log functions. So we got choice 1, but we could also take it a step farther. So make sure you got this down, and let's actually analyze the graph of a log function, right, and see what it would look like. Taking this out of the way, and then we could just go through this again another way, right? That's what it's about, having different ways to do this. So let's just say we don't even want to look at the exponential graph. Let's say we just want to let's deal with log, right? You could graph it in the calculator. What you'll find is that it's the inverse. So log base 6 of 1 is 0, because 6 to the 0 is how you get 1. So that's an x-intercept, right? So this has an x-intercept, and it's going to get closer and closer to the y-axis as we approach, as x approaches, well, x is going to approach but never reach 0, right? So the graph is going to get closer and closer but never touch the y-axis. So the y-axis is an asymptote, because you cannot take the log of a number that's not positive, because this is saying 6 to the, if this is c of x is y, 6 to the y power equals x. There is no value of y that would result in x equals 0. So x cannot equal 0. So log 6 is only defined when x is greater than 0. So the domain is the set of positive reals, and they want which one's false. It's going to have no y-intercept, since x has to be to the right of the y-axis, where x equals 0. The asymptote is going to be the y-axis. The line that it gets closer to, right, is the y-axis. You see it getting closer and closer, but never touching the y-axis. On the y-axis, x equals 0. So the asymptote has the equation x equals 0. So this is false. It's choice 1. All right? And the range is the set of positive reals. It decreases very rapidly towards negative infinity on this side. Y approaches negative infinity as x approaches the y-axis. And this way, y very slowly approaches positive infinity, very slowly, as x increases. So but the range is the set of all real numbers. So that's another way to do it, or put it in the graph. Okay? Now we're going to go to number 19. Pause the video if you need to. I need to erase so we have more space. Let's get this thing going. Okay, and study your log functions, and this won't be hard. It was a little tricky, but you'll understand it. And with practice, you'll get great. So let's look at this very carefully. The equation 4x squared minus 24x. Watch this. I'm going to highlight in different colors for a reason. Plus 4y squared plus 72y. That was too dark to be able to see. Plus 4y squared plus 72y equals 76 is equivalent to which of these three? Now, if you look at these, which of these four? If you look at these choices, we have the same thing in all three of these. The equations are the same. 4 times x minus 3 squared is the same for all four of these. Plus 4 times y minus 9 squared is the same for all four of these. The only difference that we're looking at is which of these four numbers should it be. So if you look carefully, this is the equation of a circle. If you divide all these sides by 4, you get the equation of a circle. I did not mean to do that. You get the equation of a circle. Okay? So we want to obtain on the left-hand side this equation right here, right? Now we're going to use a method called completing the square to do that. So I'm going to start off with the first two terms, the 4x squared minus 24x. I hope you could read this. If not, I think I'll switch to a little darker shade of yellow. So 4x squared minus 24x. And I'll even move this over to the right-hand side. I'll have plenty of space to do it here, guys, underneath. 4x squared minus 24x. Then I'm going to leave a little space, and I have plus 4y squared plus 72y. I'm going to leave some space again. Well, I don't need to leave space yet, actually, now that I think about it. And this is just one of many ways to do it, guys. Plus 4y squared plus 72y, and then equals 76. I could start factoring and completing the square, or I could divide all the terms by 4 to begin with. I'm going to divide by 4. And then you'll see I'm going to get x squared minus 6x, leave space this time, plus y squared, 72 divided by 4 is 18, equals, leave more space, 76 divided by 4 is 19. Okay, now when you complete the square, if you know how to complete the square quickly, you know you're going to get 9 and you got to add it to both sides. You're going to get 81 and you add it to both sides. If you're not, if you didn't understand what I just did, make sure you study completing the square. What I did was basically to get that value, this 9, this is a we want to get a perfect square trinomial. So if I had x squared minus 6x, I want to find the value that makes this a perfect square trinomial. C is always equal to the b value over 2 squared. B is equal to negative 6. Negative 6 over 2 is negative 3, which when you square it, you get 9. So that's how I got 9 on both sides. If you do the same thing with this one, b is equal to 18. b over 2 square is 18 over 2 is 9 square is 81. Got it? So that's how I got this 9 and 81, and it must be added to both sides. And you could do it very quickly in your head with enough practice. Now when you factor, the number, these are perfect square trinomials. That's why they're called completing the square. So the number you get before you square it, so this one was 18, so for x, the x trinomial completed with 9, the number you get before squaring is what's going to go in the parentheses, because this factors to x minus 3, which is x minus 3 squared. You just divide the b value by 2. This is y plus 9, it'll be y plus 9 squared. Add these three numbers, 28 plus 19 plus 9, 28 plus 81, 109. But none of them have this as an equation because of this 4 being multiplied. So you could either divide all these equations by 4 or simply do this. I'm going to scroll down, okay? Pause the video if you need to. And I'm going to write down, basically all we have to do is if we multiply 4 here, 4 here, 4 here. Remember I told you all these are the same? It's what do we get on this side? We got our 4 times x minus 3 squared plus 4 times y plus 9 squared. 109 times 4 is 436, my friends. Not any of these 4 numbers. The 76 would happen if you didn't multiply this side. So our answer is choice 4. There were other ways you could do it, but this is the way I think they meant for you to do it, by completing the square. I mean, that or some variation of it. Okay? It was a tricky thing about completing the square, an equation of circles, and kind of messing it up in the answer choices by not dividing the 4. But basically, that's what we got, okay? So moving on to the next one, number 20. There was a study done on oxygen consumption. Let me get the highlighter. I was holding my pen upside down and wondering why the cursor won't work. There was a study done on oxygen consumption of snails as a function of pH. So that means we're going to have oxygen consumption on the y-axis and pH on the x-axis because it's a function of pH. The result was a degree 4 polynomial function whose graph is shown below. Okay, and you guys don't need to be told it's a degree 4 polynomial because you could see there are 1, 2, 3 turning points. If you add 1 to the number of turning points, that'll always give you the degree of the polynomial. Okay, let's go ahead and see what the question is asking now. Which statement about the function is incorrect, meaning which one is not true? The degree of the polynomial is even. Anytime that, if we were to extend this graph, the reason it's not being extended below is because we can't have negative oxygen consumption, but it opens down. If the two arrows point in the same direction, that's how you know it's even. Just like when in a parabola, this is degree 4. All right, so it has a even, and they told us it's degree 4 anyway. So it's definitely even, but we want which one's incorrect. Right, so I'm crossing it out because this one, I'm going to put a check mark next to the one that's correct, and then the one that's incorrect is the one we're going to pick, okay, and circle. there's a positive leading coefficient. Guys, think about a parabola. When you have an even degree polynomial, the graph has to open face down. This opens face down as well. So it has to have a negative leading coefficient because it opens downwards. So that's incorrect, and that's the one we're going to pick. Okay, let's look at the next one. At two pH values, there is a relative maximum. The turning points, right? These are the two max turning points, and then one minimum turning point in blue. So yes, there are two relative maximum pH values. One of them when the pH is about a little over 7, one when it's about 9. Those two pH values give a relative maximum. And then finally, there are two intervals where it's decreasing. Anytime you hit a relative maximum, so let me erase this. There are two intervals where it's decreasing. Yeah. One, it's decreasing. I'll just highlight it, okay? I'll highlight it in yellow. It's decreasing on this interval from about when x equals 7 to about 8. So this is the interval, right, in terms of pH. Then it increases till it reaches the absolute maximum. And then it decreases until the pH is 10, so between about 9 to 10. So yeah, there are two intervals where the function is decreasing, so that's also correct. All right, so all three of these are correct except 2, and they want which one's incorrect. 2, my friends, are incorrect. 2, my friends, is incorrect. Choice 2 is incorrect. Okay, if you know your polynomial functions, this wouldn't be hard, and they kind of made it very easy by telling us it's degree 4. They didn't have to do that. All right, so moving on. We're making good pace. Question 21. Last year, the total revenue for Homestyle, a national restaurant chain, increased by 5.25% over the previous year. If this trend were to continue, meaning it's going to continue increasing by 5.25% per year, which expression could the company's chief financial officer use to approximate their monthly percent increase in revenue? So here's how this is going to look like, guys. We multiply by 1.0525 each year if this trend continues to increase by 5.25%. So y is equal to the number of years, and they mentioned here that m is the number of months. So if m is the months, guys, if I want to find for 1 year, I raise to the first power, and I just multiply by 1.0525. To the second power for 2 years, third power for 3 years, and so on. That's if I'm going higher. So how about a decade? A decade is 10 years. So I would raise to the 10th power, assuming it continues for that long. Each century, I would raise to the 100th power. So let's say I wanted to do first for a decade. You're not going to do for a century. You can't predict that. For a decade, it would be 1.0525 to the 10th power in 1 decade. To the 20 power in 2 decades. So whatever the number of decades is, if it's 2 decades, it's 10. The yearly factor raised to the 10 in 1 decade, so it's to the 10th in 1 decade. The whole 1.0525 to the 10th raised to the second in 2 decades. That's if we're going to higher percent values of time, right? But we're going to lower values. So if m is months, so d is decades. If m is months, we're scaling down. So we want to do each month is 1/12 of a year. So we want something like this: 1.0525 to the 1/12 each month. I could multiply the exponents and get 1.0525 to the m over 12. But this says 12 over m, and this one didn't do anything to the exponent. This is using the yearly factor. We can't raise it to the m for months. That's just not accurate. So these two are out. Now look, we got 1.00427. It would be this is 4.27% growth per month. I'm sorry, 0.427% growth per month. Now, I would use the calculator, raise 1.0525 to the 1/12th power, and show that you get this, but you see that 0.00427 is lower, so that makes sense. It shouldn't be to the m over 12. That's if we kept the yearly growth factor. But this would be the monthly growth factor. If you raise 1.0525 to the 1/12th power, that's about 0.427% growth per month, which is lower than the 5.25%, which makes sense. So it should become this to the m, choice 3, without a shadow of a doubt, all right? Just by elimination. You could use the calculator to confirm, but we didn't need to. So we're going to move along. This is about knowing how to manipulate exponents and exponential functions for different time periods. In this one, the variable changes. If the variable did not change, we'd do it a little differently. But that's a question for another video. Now, here we're going to use our calculator. Which value to the nearest tenth, 1 decimal place? It is not a solution of p of x equals q of x if p of x is given by this function and q of x is given by that. So I'm just going to set p of x equal to the q of x, and I could either graph both of them, look for the point of intersection, but only the x coordinates, right? Because this is the x coordinate of the point of intersection. Or I could set the equation equal to 0 by subtracting 3x and 8 and look for the roots. I'm just going to graph both of them and then look for the point of intersection. There should be 3 of them, according to this video. Wrong window. Okay, so I'm going to minimize me for now. I'm going to enter the two equations. So one of them, p of x equals x cubed, and you could enter it as y equals or y1 equals in your calculator depending on what kind you have. And q of x equals 3x plus 8. Now, I want to look for the 3 intersection points, and this window is clearly not allowing me to see all of them. So I'm going to expand my window. The x-axis doesn't need to be expanded any further. The y-axis is obviously too small. That's better for the negative side, and I still need more on the x-axis side. Okay, there we go. So we just want the x coordinates of the point of intersection. Negative 3.9, when x is negative 3.9, both functions are equal to about negative 3.8. So negative 3.9 is a solution, negative 1.1, and 2.1. So I'm just going to drag this down. One of our solutions is negative 3.9, so we're going to take that out. Because they say which one is not a solution. Let's go back. Negative 1.1 was the other solution. Then 2.1 to the nearest tenth was the positive solution. None of them were equal to 4.7. All right, the other thing you could have done was if you subtracted 3x minus 8 on both sides, set the equation equal to 0, look for the x-intercepts. But, you know, I say tomato, you say tomato. That was the main method. You could have also used the polynomial equation solver if you have that app in your calculator. Now, moving on to 23. The population of Jamesburg for the years 2010 to 2013 respectively were reported as follows. So this is the 2010 population is 250,000. 2011, 2012, and 2013. All right, how can the sequence be recursively modeled? So first thing, in a recursive function, it must, so they're using J for the population of Jamesburg. So a recursive function must start by stating the first term and saying what are you doing to the previous term, j of n minus 1, to get the next one. So the fact that these two are not doing that, these are explicit formulas, eliminates choice 1 and 2, and we're down to 50-50. Sweet. J1 is 250,000. The first year, 250,000. Both functions are telling us that. So we got that. I'm going to erase these two other choices that don't work. All right, I'm just going to scribble them out so that we don't look at them. These are explicit and not recursive. All right, so both of these give the correct original value. Now in choice 3, we're multiplying by a constant amount, while in choice 4, we're adding 937 each time. So we want to find out which one it is. So I'm going to go back to I'm just going to go to the calculator, the scientific calculator, and I'm going to use choice 3 first. All right, I'm going to use choice 3 first. So in choice 3, we're multiplying the value by 1.00375 each time. So the first term we already know is 250,000. Maybe if I make this smaller, that'll help. So the first term is 250,000. The question is, would multiplying by 1.00375 help me get the correct value for the second term, which is 250,937. I'm trying to fit this, guys. So here we go. 250,000 times 1.00375, or we can multiply first. Let's just make it the way it looks there. So 250,000 is about 250,937.5, which, you know, we can't have decimals, but that doesn't necessarily rule it out because it's close so far. So I'm going to erase this, guys, and I'm just going to check off I'm going to use now red for choice 3. I'm going to check off the ones that work for red, right? So J1 is 250,000, that works. And this works so far. Now what I'm going to do is I'm going to take the next term, which was 250,937, and I'm also going to multiply that by 1.00375. And I'll just hit the times button this time instead of putting parentheses. It's less work. And we get 251,878, which checks out so far. Now I'm going to just multiply the next value. I'm going to do 1.00375. I guess the parentheses look better. Or 251,878. And I get 261,000. I was supposed to put 2 zeros here. 252,822.5-ish. So it worked. Let's see if the other, so this was a geometric sequence, right? So it seemed to work, not exactly. If the other one works better, I doubt it will, then we'll pick that one. So we're adding 937 in each one for choice 4. So that works even better so far, with the first term being equal to 250,000. I'm going to use blue for choice 4. Right? I'll erase this and let's just see if it checks out for choice 4. If it does, let's see which one works better. So far choice 4 works better because both of these were exact, whereas in choice 3, it wasn't. Now, let's see if it continues the pattern. So 250,937 plus 937 is 251,874. So already we're kind of a little low here, so it's not looking good. And if I do the third term, 251,878 plus 937, I get 252,815. So even though that's not bad, the exponential was a lot closer, so that's the answer we're going to pick. Choice 3. All right, I didn't like this question too much, but it wasn't terrible. It was kind of annoying, I guess. All right, we got one more, and this is, again, recursive formulas. See, these recursive formulas are big, and this should say j of n is approximately equivalent to, because it's not exact, 1.00375, because we can't have decimal number of people, and we get a lot of decimals when we multiply these, times j of n minus 1. So I'm going to put this to be approximately equivalent to, but not exactly. Answers without a question, choice 3. 24. Last multiple choice question, guys. Here we are. The voltage used by most households can be modeled by a sine function or a sine curve. The max voltage is 120 volts and there are 60 cycles every second. Which equation best represents the value of a voltage as it flows through the electric wires where t is the number of seconds? Okay, so what we're going to do is, we know that the max is 120. Let's look at these one by one. If I have a function v equals a sine of bt plus c, all of the midlines here are 0. If you know from a previous video, to get the maximum, you do the midline, which is c, plus the absolute value of a. That's called the amplitude. Amp, the tude. C is the midline. All the midlines are 0. All the amplitudes are 120, because if you take all the a values are 120, a equals 120 for all of them. And if you take the absolute value of 120, it's just 120. So the midlines are all 0. So if I do 0 plus 120 for any of these, all of them have max of 120 volts, right? So that is taken care of by all the equations. That doesn't really help us. But there are 60 cycles every second. So this is where we get into, you see, the only thing we're looking at now is all of them have a max of 120. So this was not really useful for us because they didn't even have to tell us that. Basically, we want to see which one has 60 cycles per second. So here's what we got, guys. The period is the amount of time needed to complete one cycle. So I'm going to go over this two ways, all right? If there are 60 cycles in 1 second, then how many cycles? P is the time period, right? So that's to complete one cycle. So one cycle would take how many seconds? P is the period, right? If I multiply these, I get 60p equals 1, then p is equal to 1 over 60. There are other ways I could have done that too, but that's one way. So the period is 1 over 60. Now, the b value is the frequency. So since this is 0, we don't need this part, all right? This is called the frequency. P or b times p is always equal to 2 pi. So the frequency times period, which is 1 over 60, is equal to 2 pi. Multiply both sides by 60, and you will eliminate the 1 over 60. So b is equal to 60 times 2 pi, which ends up being equal to 120 pi. I know I'm running out of space. So the equation then should be v equals 120 sine 120 pi t, which is choice 4, beyond a shadow of a doubt, like I said before. There were other ways to do this, but I don't want to complicate things, so we'll leave it at that. I know I said I'd do it another way. If you really want to see it, ask me in the comment section below, but let me come say goodbye, and I'll do it if you ask me to. All right? Wow, it's getting dark here. I didn't realize how dark it got. It's 8:36 right now. I had to redo some of these videos because I look like I'm in a horror movie right now. I had to redo these movies because these videos, I'm thinking of Blair Witch right now, or like Paranormal Activity or something. Um, Ooh, it's kind of spooky out here, guys. This math video turned scary. Anyway, let me stop. Um, I had to redo some of the videos because they were too long, or there were some mess ups, and YouTube didn't let me put them up until like they're within a certain time limit. But anyway, I like to close the same way. You know me, if you've seen my videos before. If you have any questions, let me know, and I will respond to you as soon as I get the chance. You, the I wish you the best of luck. Please study. Do your absolute best, okay? And believe in yourself. Get some good night rest each night, especially as you near the exam. Ask questions. Ask me the question. Ask your friends. Ask your teacher. Anything that I could do to help you, let me know. Make use of every single resource you got, right? Research online. And I will ask, if you enjoyed the video, please hit like and subscribe. I would appreciate that very much. If not, it's cool too. But I'd just like to ask, that would help me. It would make me happy. And any comments, anything you want to share with me, I'll be more than happy to hear, okay? So take care and best of luck, guys. Take care. Bye.